Hello everyone, welcome back. So today we got a laptop for repair. So especially I thank all the subscribers for subscribing our channel, and we are trying so hard to provide you more informative videos and more useful videos in the near future. And so stay tuned with our channel, and we will be posting all the videos in a sequence manner. So this laptop came to our shop for repair. So the problem with this laptop, it doesn't turn on. So this laptop is similar to the one that we discussed earlier, which is the customer, they try to repair the display problem by themselves and shorted the CPU and entire motherboard, and it was a no repair. We can't repair that motherboard. So likewise in this laptop here, the customer tried to service the laptop by themselves. So they said it was so dirty, so they tried to remove the back cover and tried to service the laptop. After servicing the laptop, they tried to turn on, it didn't turn on. So the laptop became dead after doing those services. So anyway, let's check this motherboard. So always I request all of you and advise all of you to remove the battery before doing anything on the motherboard. So as the customer said, I think they have not removed the battery before doing any changes in the motherboard. So actually the battery connector is so tight than the display connector, so it will be more easy for them to remove the battery display connector before removing the battery connector. So, and it is obviously easy to remove it, so that's why they would have gone to the display connector first, then to the battery connector. So I don't know anything. Anyway, we'll hope for the best in this laptop. Let's try to diagnose the problem in this laptop and try to fix it and solve the problem for the customer. Okay. Okay, now let me connect the adapter from the power supply and just see whether if there's any current consumption from the power supply. So I have already connected. You can see here I have connected, but still I have no reading on the power supply. You can see there's no reading. Okay, now let me open the laptop and let me press the power button. No symptoms, no reactions. So we have a nice quote here: life begins at the end of your comfort zone. Yeah, so when we go out of our comfort zone, our life begins. Okay, so let me try to remove the back cover and just go for a checkup from the DC jack, then to the main power rail in this motherboard. So that is a 19 volt, and then we can check some of the voltages on this motherboard, and after that we can remove the motherboard out of the laptop and check everything on the motherboard. Okay. Okay, so now I have already removed the back cover, and we need to check the command point on this motherboard, which is here, which is the DC jack. So I will just connect the DC jack here. Okay, now it's connected. Let me grab my multimeter and start checking the main power rail. Okay, always it is very important to disconnect both of the connectors, which is the battery connector and the display connector, before repairing or before servicing anything on the laptop. Okay, so let us check on the command point at the starting of the point here. The voltage is on DC jack. Okay, we don't have anything. Wait a second. No voltage. Yes, we have a voltage, so the ground is not appropriate in this place. Okay, right, we have 19 volt on the DC jack, and this capacitor normally filters the main power rail, which is the 19 volt or 12 volt. We can check that one. So we don't have the voltage there, therefore the first and second MOSFET is not switching the 19 volt from the DC jack to the entire motherboard. So that's why we are not having a voltage on this point here. Okay, now let me take out the motherboard so that we can inspect carefully everywhere around the motherboard to see physically if there's any burn marks or short circuit on this motherboard. So let me take out the board first. Okay, so now the board is out. So let us check all the voltages on this motherboard, and also we need to check the diode value in order to see whether all the coil readings are correct, the inductor readings are correct. First of all, let us check for any damages or any short circuit burn marks on this motherboard. It looks fine on this area. It is okay. So what about under the protective cover? Yes, here we have the EC chip. Actually, this motherboard is same as the one that we were discussing earlier, which we had the short on the CPU due to disconnecting of 19 volt from the LVDS connector back to 3 volt. So I don't know what's the problem in this motherboard. Anyway, let us diagnose it and we can find it. Yeah, there's no problem. Okay, on the other side. It looks like someone has already tried to repair something, or else it's from the manufacturer side. So you can see there's a small flux residue near the screw hole. I don't know. Okay, let's leave it alone. Okay, everything look nice. Okay, so let's start up a check from all the inductors for diode values from the current sense resistor first, and then back to ground. Here we have a common point, so which is directly connected to the current sense resistor, so we can probe the negative probe on the positive end of this capacitor, and the reading shows 500. Okay, 400. Okay, 400. Okay, 400. Okay. Okay, actually we were reading 0 ohms on the current sense resistor on the previous motherboard that we were checking, which had the short in the CPU. But on this motherboard we are having high impedance on the current sense resistor. You can see here we have high impedance. Therefore, I think there is no much problem in this motherboard. I hope that we can solve this motherboard. Okay, let me see. Here we have another inductor. Yes, 400, 500, okay, 400, okay. So everything is fine. So the upper MOSFET is okay. Let us check the lower MOSFET. Yes, 500, 300, 120, 129, okay. So this is GPU coil. So the GPU inductors will always be even lower resistance than the CPU. So that is normal, okay. So this is 97. Most probably this should be like 3 volt and 5 volt standby voltages, okay. So 3, 6, and this one is 97. It is little bit lower, okay, but this is not too much. Let me check reversely. Yeah, 174, okay, no problem. Maybe this one is of the RAM regulator. Let me see that. Yes, so this is the RAM coil. So that's why we are reading low ohms in this point. Now we are reading 184. That is okay. And now we are reading 236. That is perfect. So there's no problem. And this is the RAM coil which supplies the voltage for DDR4 on this motherboard, which is 1.2 volt approximately. Okay, so there's no short on this motherboard, so it's a good symptom on this motherboard. So we can check from the first and second MOSFET why they are not switching voltage to the motherboard. Okay, let me connect the adapter. Okay, now the adapter is connected. So we need to find where is the first and second MOSFET. First and second MOSFETs. Where is that? Okay, so this is the inductor which is connected directly to the DC jack on this point here on the other side. So we can check the voltage on this inductor. We should have 19 volt. So we should have 19 volt on that inductor. Yes, we have 19.46 volt. Okay, and where does it goes? So it will go to the first MOSFET in this motherboard. Okay, let me see that. Where is the first MOSFET? Actually, the trace is ending at this point here, and you can see there are some small holes. We call it as vias. So the voltage goes into this motherboard from this place, and it goes somewhere internally around the motherboard. So you can see physically the trace is stopping at this place here, and it going internally to somewhere in the motherboard. So we have to find that. Okay. Yes, so you can see here. So this looks like the battery connector is here. So the charger IC is here, something I guess. And you can see here, it looks like the first and second MOSFET. So this is the first MOSFET, and this is the second MOSFET, and here we have the current sense resistor. So I'll give a zoom. it's little bit different than we checked earlier with that motherboard. So anyway, somewhat similar. Okay, so this should be the second MOSFET, I guess, and this should be the first MOSFET. And no, actually the bigger one is the first MOSFET and the second one is the second MOSFET. The small one is the second MOSFET. Okay, because the second MOSFET is only connected to the current sense resistor directly. So this is the second MOSFET. So we can check the voltage on the first MOSFET. We should have 19 volt. We should have 19 volt. Yes, we do have 19 volt. And also you can see here there are some marks, which means so someone has tried to repair at this place. It's obvious and it is clear. So someone has replaced this MOSFET or tried to remove this MOSFET from this place. So already they have taken to some other repair shops. Okay, let's see. Okay, so let us check the voltage on the gate pin of this MOSFET. So we should have a higher voltage than the source, because this is, I guess this should be the N channel MOSFET. So on the gate pin, so we are reading 0 volt. So on pin number 1, 2 and 3 is source and pin number 4 is gate, and we are reading 0 volt. That's why we are not getting this 19 volt on the other side. Okay, so we need to check the requirements of the charger IC in this motherboard in order to see why they are not switching the voltage. Okay. So first of all, let me check the both of the MOSFETs in this motherboard, the V-in MOSFETs. So we can use the diode function for checking this one. So we should have reading only on one side. So the diode direction for N-channel MOSFET is from source to drain. So we need to keep the positive probe on the source side and also the negative probe on the drain side. So the diode direction is pointing out this way. So the cathode of the diode is on this side, on the drain side. Yes, we are reading 481. But if we reverse the probes, we should read high impedance, which means the diode is now reversed. So you can see there's no reading, which means now it's in reverse connection. Okay, what about the other one? So this one, the source is on this side and the drain is on this side. Okay, so we need to keep the probe on this way correctly. Yes, we have 523. So both the MOSFETs are fine. There's no problem in both of the MOSFETs. Okay. So then why these two MOSFETs are not switching voltages? Okay, anyway, let me check the requirements of the charger IC. So it is an intersil charger IC, you can see here. It is an intersil charger IC which is 95522AH. And the charger IC should receive 19 volt on this 10 ohm resistor, and it goes as a supply to the charger IC. So let us check that voltage as well. So let me connect the adapter. Okay, now the adapter is connected. 19.15 volt. Okay, 19.14 volt. Let me check the resistance value of that resistor. So we should have accurate value of 10 ohms on that resistor. Always disconnect the adapter while checking this type of resistance on the circuits, otherwise sometimes you will get a wrong reading. So again I will connect the adapter. So the 10 ohms resistor is fine, there's no problem. Okay, now we are in a situation to open the schematics to understand more about what is happening on this section. And this diode looks like a double diode which provides the power source from both power source, so from the adapter and also from the battery. So when there is no adapter voltage, this double diode will power the charger IC from the battery, and when there is when there is an adapter, the battery voltage will be blocked, where the highest voltage will be allowed from this way to this pin here to the resistor, and it will go straight into the charger IC. Okay, so let me check the voltage on that diode. So we should have 19.5 volt. Yes, 19.4 volt. And on the output side, it's 19.15 volt. This is because of the diode drop value. So for all of the diodes have a basic quality, which is it will drop about 0.7 volt or 0.304 approximately when the diode voltage is in a forward direction. So it will drop a voltage and it will send the rest of the voltage on the output side to the sections it is required. Okay, so let me open the schematics so that we can understand this very well. So we have to find it whether we have schematics for this model. Okay. Okay, so we were able to identify the schematics of this motherboard, and also we are blessed with the board view of this motherboard, so we can easily find the components on this board with reference to the schematics, so it's easy for us to find that as well. Okay, so this is the charger IC of this motherboard. So you can see it is ISL 95522HRZ, so which is the charger IC in this motherboard. So we need to check its requirements for it to give those drive for the first and second MOSFET. So these are the two first and second MOSFETs. So these two MOSFETs should be given a drive voltage higher than the source. So basically the source voltage will be equal to the 19 volt, the adapter voltage. So normally the internal MOSFET, which is on the main power rail on the V-in side, will be having 25 volt as the drive voltage to the gate of these MOSFETs, so that when these MOSFETs receive 19 volt, higher than 19 volt on the gate pin of this MOSFET, like 25 volt, so they will conduct the voltage from the other side of the board, and we will be having 19 volt on the current sense resistor here. So we need to check one by one. Okay, so we have the gates of the two MOSFETs are interconnected, and on the common point of the interconnection we have the AS gate charge, which comes from the charger IC to drive these MOSFETs. So first of all we need to identify the requirements of the charger IC. So first point is starting from the input for the charger IC, which is either the 19 volt or from the battery power. So there will be a resistor on the input side of the charger IC which filters an excess current on that, and which is for protecting the charger IC and also other components on this motherboard So when there is a short on this charger IC, so this resistor will increase its resistance and it will protect the other sections in this motherboard. Okay, so we need to check on pin number 17 whether we have the 19 volt, and also after having the 19 volt on pin number 17, the other voltage we should check on pin number 8. So once we receive the 19 volt on pin number 17, we will be getting a 5 volt on pin number 8. So you can see here it is VDDP, means it will be 5 volt. On some other charger IC you might find like REGN. So REGN means it is 6 volt. So according to this charger IC, we can see this is VDDP, which means that is 5 volt. So we need to check on pin number 8 whether we are getting 5 volt. Also we need to check on pin number 16, which is the adapter detection signal to the charger IC, and with regard to the adapter detection signal to the charger IC, it will send AC OK. So when the AC in pin is validated, then it will send a signal on the AC OK to inform to the EC chip that the adapter is connected. So once we receive AC in signal, we will be having a high logic on the AC OK signal. So we need to check that as well. That is on pin number 16 and also on pin number 24. So we need to check on pin number 17, it should be 19 volt. On pin number 8, it should be 5 volt. And we need to check after all 4 signals on pin number 7, which should be 25 volt, which is the boost up voltage for the first and second MOSFET in the main power rail. So we need to check all these things in the charger IC, and let's check it with the motherboard now. Okay, so this is the charger IC. So we have to check on pin number 8 whether we have 5 volt, which is the VDDP voltage. So this is on pin number 1, 2, 3, 4, 5, 6, 7, 8. So we can check on this capacitor here whether we have the VDDP voltage, and also we need to check on pin number 16, which is the AC in voltage. So that is on pin number 16. So this is 8 and this is 16, it's here. So we can check on this resistor here. Okay, the other signal is on pin number 24. So this is 8, so 16 and 24 on this side here, on this edge here. So we need to check on this point whether we have the AC OK signal. So normally this will be around 3.3 volt. So let us check on this. Okay, now let me connect the adapter. Okay, now the adapter is connected. Right. So on this capacitor, yes, we do have 5.3 volts. So the VDDP voltage is present. Okay. So we have to check on pin number 16. That is on this pin here. Yes, we have 2.3 volt. So normally we should have around 2.4 to 3.14 volt, but we are getting 2.3, which is approximately okay. Anyway, let's see the other pin, which is the pin number 7, which gives the AC drive voltage. Let me see once. Yes, the pin number 7 is here. No, we don't have any voltage. We have around 1 volt, 0.1 volt or something. So that is not a voltage. Okay. So we need to check some other sections in the charger IC. So why there is no drive voltage for the first and second MOSFET? So what about AC OK? On pin number 24, it's here. Yes, it's 3.1 volt. So we are having 2.3 volt approximately on this pin, but we are having 3.1 volt on this pin, which means the charger IC has detected that the adapter is connected. So 2.3 volt is okay at the AC input signal in order to release the AC OK on the 24 pin on the charger IC. So it's 3.1 volt okay. So that is also fine. So why we don't have 25 volt boost up voltage on pin number 7? So we need to identify that. Okay. Right. Now let me remove this current sense resistor from this place and check whether we have a 19 volt on the current sense resistor, just to see whether if there's any short or any low impedance on the current sense resistor. Now once again I'll just check the ohms value or the impedance value on the current sense resistor. Okay, so we have over limit of resistance. So the impedance value is so high, so there's no problem. So if we reverse the probe, we are reading 400, so that is okay, there's no problem. Okay, so what would be the problem then? Now let me check whether there's any continuity between the MOSFET gate and the source. So we should not have a continuity from the MOSFET gate and source. Let me check that as well. First of all, I just disconnect the adapter. So this is the source and the gate. No, we don't have any short between them, so we have high impedance, so that is 700. okay. On the other side, the small one, yes, they are over limit, there is no problem. So actually the problem is only with the charger IC. So we are reading 600. So the problem is only with the charger IC. So it is not giving the charge pump voltage. Inside this charger IC, it has a charge pump which provides 25 volt for the first and second MOSFET. So we need to identify why the charger IC is not giving this drive voltage. Okay. Now let me remove these two MOSFETs and see whether we have any drive voltage at the gate of these two MOSFETs. Okay. Okay, now the MOSFET is out. Let me cool down the board a little bit. Let's check on pin number 4, which is the gate. We are having 4.9 volt. Okay. It's so strange. Why 4.9 volt? We should get 25 volt actually. 4.8 volt. Okay. Okay, now I think we had to refer the data sheet of the charger IC in order to understand how this 25 volt of the charge pump inside this charger IC is functioning, because now we are not getting any voltage on the gate of these MOSFETs. So now we are reading just 5 volt. So the 5 volt is not appropriate. Okay. Anyway, I'll just try to place one of the MOSFET in that place and check whether we have a dry voltage. Okay. Okay, that is well fit in its place. Okay, now I have connected the adapter again. Let me check on the gate pin of the MOSFET. Okay. Yes, we do have 24 volt. Okay, that is fine. Amazing. So we have 24 volt. Okay, that is nice. So with one MOSFET, we have 24 volt. So what is happening if I place the other MOSFET in that place? So why are we getting 5 volt there? Okay, 19 volt on the gate pin. Yes, we have 24 volt. Okay, now let me check the MOSFET that we removed earlier. Where is that one? I missed it somewhere. Oops. So here we have the MOSFET. This is an N-channel MOSFET. So this is reading 200. So 200 is very less. So we should have around 400. So I think this MOSFET is gone shorted slightly, not perfectly. So it's slightly gone shorted with the drain to source. So that's why it's reading 200. Yes, 200. 200 is not appropriate. So I'll just test it again. So we can reset the MOSFET just by touching our hand on the top of it. So just to show the drain and the source pin. So we'll check it again. But while we were checking earlier, we were reading a good value before. But after removing the MOSFET, it is reading very low diode value. Why is that? Okay, anyway, I'll just check it. Yes, it is same as before. Okay, let me check with the reverse polarity by swapping the probes. Okay, which is an over limit. So okay, this is over limit. I think someone has placed this MOSFET who took from somewhere else. This is not appropriate for the V-in section, I think, because the diode value is reading 200. So we should not have this type of MOSFET in this place. So let me check its value, the model number of this MOSFET. So where's that? I'll just give a clean. I couldn't see the model number. Yes, it's visible now, which is 77702. I think, yes, it's 7702. Yes, it's visible, 7702. Now we have to refer the schematics whether we have the same MOSFET on that board.
Okay, now according to schematics, so this is the PQB12. So here we should have AON7506 MOSFET. So this is the model number of this MOSFET. But we had on this motherboard is AON7702A model. Okay, so this is the data sheet of 7702A model MOSFET. So this MOSFET can handle up to 30 volt from drain to source. And if you look here, we can go straightly to the power dissipation, which means it will measure in the watts. So there's a two models like B model and A model. On A model, it can handle only up to 3.1 watts. Actually, this is the model that was placed on the motherboard. So 3.1 watts is inappropriate for the V-in section because it is the MOSFET that is responsible for drawing the current from the adapter back to the entire motherboard. So it should be capable of handling more wattage. So in that case, the power dissipation on the B model would be appropriate for the V-in section after the first MOSFET. So 23 watts is appropriate for this one. But so in that case, so we should choose the B model, not the A model. So according to the schematics, we are having 7506. So which is also the same as before. So they handle 30 volt from drain to source. And when you look at the power dissipation, here also we have the same model, which is A and B. And on A, it can handle up to 3.1 watts, and B, it can handle up to 20.5 20.5 watts. So we need to place 20.5 watts on the second MOSFET. So that is B is appropriate. But I don't have both of the MOSFETs with me, but I have a different model, which is this one here, which is A0N7410. Actually these are all same, only little bit difference between these types of MOSFETs. So this MOSFET also handles 30 volt from drain to source. And if you look here, so on the power dissipation we have two models like A and B. On B it can handle up to 20 watts, and also on the A it can handle up to 2 watts, sorry 3.1 watts. So I have with me the B model. So now I am going to place the 20 watts on this motherboard, and let's check whether we have 19 volt on the main power rail. Okay.
Okay, so I can place the MOSFET here. Yes. Actually, I am very familiar with this MOSFET because I have placed this MOSFET in several motherboards and I have no return of the motherboards for repair. So this is a good MOSFET which can handle a high current. So let's place it and check it. Okay, that is well fit in its place. Everything is fine. Now let us make the motherboard to cool down. So this time I'm going to show you the display of the power supply, so you can watch the current drawing from the power supply by the motherboard if this MOSFET are switching properly, right? Okay, so the power supply is visible to you now on the screen. So now I am going to connect the adapter. You see the ampere is taking around 1 ampere. So actually the board has turned on. You can see the light is glowing. Okay, so we have solved the motherboard. There's no problem anywhere in the motherboard except on the first and the second MOSFET. So it's taking around 1.13 ampere, so which is perfect for the motherboard to execute the display. So that is fine. So the problem is only with the second MOSFET, which is here. So always try to replace a MOSFET that is appropriate in the section. So you can replace a MOSFET interchangeably, but you have to consider its power dissipation, whether it can handle high current or not. So this MOSFET, which was already in the motherboard, so it can't handle a high current. So you can see the model number is 7702, and you can see there's an A, so which is the A model of the 7702. So it can handle only 3.1 watts, which is not appropriate in the V in section at this place. So if you place this type of MOSFET, it will again get shorted and the charger IC will not give the right voltage at this point. So always consider replacing a MOSFET So you can replace a different brand or different model MOSFET, but you should consider whether it can handle a high current or a current that is in a specific place. Okay, now I'll just show you the gate voltage on these two MOSFETs after replacing it. So already the board is turning on. So we should have 24 volt on both of the gate of these MOSFETs. So let's check it one by one. So on this pin here we have 24 volt on the first MOSFET, and on second MOSFET also we should have 24 volt. Okay, so both MOSFET are switching properly. So there's no problem with the motherboard. So actually we don't know what happened when the customer serviced the laptop. So anyway, I think the first MOSFET or second MOSFET gone shorted and the motherboard became dead, and they took it to another repair shop, and I think they have tried to change the MOSFET in this place, but they have not replaced the correct one. So that's the problem. So anyway, we have found the problem, and the customer is actually a lucky person, so he saved the laptop. So it's this motherboard is having a GPU in this motherboard, so it's really a costly one. So we have tried to repair this as well. Okay, so now I will assemble the motherboard inside the laptop and go for a last checkup whether we are having a display and whether the motherboard and the laptop is working fine. Okay, so if you look at the casing of the motherboard, which is above or under the keyboard, you can see here it looks like a water damage on these areas, or else the customer might have used some spray to clean the areas. So I don't know, but anyway, this will not do much on the motherboard, I think. So we'll just leave it as it is. Okay, so let's go for a last checkup. So I have connected everything in the motherboard, in the laptop. Okay, right. So now I am going to connect the adapter. Okay, now I have connected. Look at the ampere reading on the power supply. Yes, it's taking 66. So I think the battery is charging up. So it is boosting the current from the adapter, from the power supply. Okay, so now let me press the power button. Okay, now I have pressed. Yes, it's taking around 1 milliamps and then back to 800 milliamps, 900 milliamps. Yes, you can see the display is executed. So that's nice and it's amazing. Okay, so it's just a simple solution, just changing the MOSFET, everything is working fine. Okay, so I'll just give a clean around the area. So it looks a little bit dusty, so I'll just clean it everywhere and connect everything. So I have not connected the back cover. So I have not connected the back cover here, so I'll just connect the back cover and clean everything, and let's go for a last checkup. Okay, so I have cleaned the laptop, so it looks fine, so pretty nice. So you can see here I have just tried to clean the laptop. So anyway, there are some marks, keyboard marks on the display, so we can't do anything with that. Okay, so let's go for a last test. So let's see whether the Windows is booting up. So I'm pressing the power button. I'm not getting any display. Okay, let me connect the adapter. Yes, we do have a display. Okay. Yes, the Windows is booting. Yes, everything is okay. So it's working. Right. So we were able to repair this laptop. So thanks for watching. So stay tuned for future updates. So bye for now.